QD Plus tool is independently developed by Shanghai Zhuli Electronics Co., Ltd., with 13 years of experience in automotive front-end development and verification, and cooperates with domestic mainstream car manufacturers to develop automotive instruments. Handrail screens, air conditioning screens and other products. There is also penetration in industrial control. QD Plus consists of two parts: APIs and visual development tools. The API is fully open to C source code. It is convenient for customers to port to the corresponding platform. Compact and flexible and fast to run. QD_HMI folder. HMI_data. This directory is data generated by the QD Plus tool. Among them stressors.bin documents. Store data information such as font libraries and pictures. .rom file mainly stores the properties of various elements in the form of arrays. For example, XY position, width and height, transparency, and relationship with parent and child nodes. When we generate the code, we can run it directly after compiling the burning.bin. Bin files can be independent of the file system. Let's add the QD_HMI code to Source Insight. From the right, you can see that this is all the files in our QD_HMI directory. Where HMI_loop.c. HMI_GFX_loop is the main function of the API. HMI_GFX_loop runs periodically as a thread. In general, 60 times per second, it can be run without OS. HMI_GFX_loop consists of two parts: updata and render. Updata not only handles touch flat messages, actions, statuses. User_process function is also called. This function will pass the touch message in. Call the QD_plus interface in the user_process. Render is calculated based on GFX_updata. The area that needs to be refreshed is painted. Next, let's introduce the QD tool. Open the QD tool folder, find the exe file, and double-click to run it. This is the visual editing interface of QD+, saved in the QD_HMI directory. Inside the configure is our CPU, as well as the configuration of the color format. Inside the application is our design interface. First, from project, set the generation code path. Here we generally select the subdirectory of the directory where the XML is located. For example, we just saved it in QD_HMI directory. We first find QD_HMI directory. HMI_date inside, generate code, are all placed in HMI_date directory. Here you choose the encoding format of the font library. For example, Unicode encoding. GB2312, GBK, etc. The chip we currently support is Cypress TVII. Here you can choose whether the resource generates .bin file. If checked, the resource will generate .bin file. Here you can also set the header information of .bin file. For example, .bin the version number of the file. QD supports dual screens. If we had a second screen, you can check this enable to set the resolution of the second screen of the screen. This select image is generate some of our image resources into prime groups. Here you can select the ID of our image. If you don't need it, don't choose it. Below are the documents that can be .bin our work. Split into multiple .bin files. Then support up to 15 .bin files. Add our screen information to pages. Right-click and select Add Page. The default is new_pages 3. Here we can change the name of page. For example, the width of the main_page is 640 × 480. We can add a container under the page. It represents the display range of our area. Change your name main_container. This width is first set to be as large as the screen width. His width and height can be set according to the actual display area. Container properties can rotate, zoom, and gradient. Also check the dynamic attributes. Then below container we add an image. Show a picture. This is an ordinary picture. There is no alpha channel. So the image type is normal image. If the picture has an alpha channel, then you can choose alpha image here. Here image fill can select the resources of our images. Here the XY width and height are the display position of the picture and the width and height. Below is the rotation information of the image. Image angle can set the rotation angle of the image. It has two rotation modes. The default is to rotate by the center point of the picture. You can also set to rotate to a specified point. Then below is the compressed format of the picture. QD supports different compression formats. Format of the image. Support ARGB 8888, ARGB 565, ARGB 1555, and A8A4 format. This is when you can set the rotation of the image. And with a small tail. We call it tailing. If here the setting is set to true, Then we can choose image tailing, the direction of appearance and the material of the tail. That is, the trailing picture. Then the tail appeared. When we want to add multiple images, we can find it by right-clicking on the container. Add multi-image and add multi-image. Add multi-image is to add multiple images. Add multi-image is outside of the image you added. Another layer of container. This allows us to determine the display area. Now let's take a look at Add Multi-Image. At this time, we can select multiple images. Let's say we choose this set of images. Set the compression format of the image. Whether to open the alpha channel is checked. Then give this group of pictures a prefix name. Under this main_container. And all the images we have just selected appear. This allows you to add multiple images at the same time. After adding the image, we want to display the page. Click Generate C to generate the C code. At this time the image resource and its display relationship have already been generated in the HMI_data directory. We can burn .bin files to external flash. At this time, we want to be on the board. Display this page. We also need to add an API. Right-click on this main_page. We need to open this page. So we need to right-click on this ID. Then get _element_ID. Get the ID of this page. And then in us. After get. Inside our source insight. Go to this client program and press Ctrl+V. So we are. If you compile and run, we can display this page on the board. Just use an API. If we want to make this image movable, or if we want to make this picture spin, we need to tick the dynamic attributes of the image in QD. When we think about dynamic properties, it's XY width and height, alpha and angle properties. We can all move it inside the API. For example, I want to rotate this image. We can see it on this picture. After checking the dynamic properties, right-click on the image. Then get the element ID. Get an ID of its rotation. Then go to the API side and Ctrl+V. QD has pasted out the API. At this time, give a rotation angle. This angle is a floating point number, so we give 30.0 f. This is how the compilation runs. We can display this page and rotate the picture 30 degrees. Same. If I want to move the XY width and height, I also right-clicked on this ID. Then get element ID. If I want to move X, then I get its X ID into the API. Paste Ctrl V. Then the ID of X in this picture. We can assign a value to the ID of this X. If I want to move it to a position where the pixels are 20. In this way, we can achieve the display position and rotation of the image we want. Now under this container, if you want to display text, we can add an add text with an add element. Add a text editing box. Then we can set the alignment of the text. Left alignment, center alignment, or right alignment. Or multi-row left alignment, multi-row centered alignment, multi-row right alignment. We can also set the color. RGB can be entered here. It can also be selected in the color chart. We can set the font ID. That is, font library information. Font size. The font ID is preset in the resource. We can add one to it in advance. The font information we want. This is the scope of the font library. Coding range. This is usually an ASCII code or Unicode encoding. Then this is the dot matrix of the characters. We are here. You can choose the font and font size you use. Note that the unit here can be point. It can also be a pixel. You can also give one here for the file name. Just give a txt file. We need to convert the txt file to Unicode encoding format. Then load in. We will put this txt file in QD. All text generates a corresponding dot matrix, including those within the scope of this font range. If you don't add it, then the font point generated by QD, font range, and use this default font. The default characters given in all text will generate its dot matrix. If we need to use the horizontal screen as a vertical screen, we need to use it here. Or vertical screens. When used on a horizontal screen, we can rotate the text generation by 90 degrees. Or rotate 270 degrees. Back to app. Back to text. We use a default font. This dynamic font if checked. We can modify the font library in the API. Set it to other font libraries. This one is numbers or chars. Is the maximum number of characters in this text. For example, a maximum of 20 strings. Set it to 20. Whether the character is displayed in landscape or portrait orientation, or vertical bottom alignment. This is whether the characters can be edited. Set to false. You can edit the characters. You can change its characters in the API. If set to true, it just can't be changed. It can only be preset in the tool. I need to show the characters. It cannot be changed in the API. When the order is set to false, this dynamic works. At this point, the string we initialize is edit. We changed it to ABCDEFG. You can see that the right side has been changed to ABCDEFG. You can also set the scrolling of the characters below. When our string exceeds the length of the text box, you can set character scrolling information. If you take this off, in the API, we can scroll through this character setting. This dynamic property. It is the chosen word. Its XY width and height can be changed in the API. At the same time, the rotation and font ID above are dynamic fonts. If changes are needed, this dynamic attribute needs to be checked at the same time. If we want to change it in the API, our string information. At this point, we right-click on the text. Then get the element ID. Select ID. Can be seen. This is QuodiX's second application API. The above three are the same. Is the first application API. This is the second application API. QuodiX has a total of 2 application APIs. Convenient for customers. Reduced learning costs. If we want, change the string. Then we need to define one first. String information. Set a new string. We need to encode characters. Zero as the end mark. When we call this API, we give this new string to the second parameter. At this time, we will compile and run. We will show it in text 13. Our new string content. our dynamic properties are ticked. And when the dynamic font is hooked, we can switch our font library in the API. Let's start by adding a new font library information. Sed new underscore font 4. At this point, we want to switch our font library in the API. We need to regenerate the code first. Then right-click on the new underscore text 13 get element ID. Then select ID. Here you need to pay attention. Only set strings. We need to set when the string changes. This is the API that needs to be used. Then if we want to set the font, then its API should be set underscore object underscore info. Then our ID should be given to underscore font. Then give a new character. Let's remove this bar font as well. Then it's the settings, and use the call to set underscore object underscore info this API. Then the ID is given to text 13. The second parameter gives us the font ID we want to set. Font ID we can enter directly. Yes new underscore font 14. At this time, we can enter it here. After the compilation runs, the font ID of our text will be replaced. It will be displayed using the dot matrix of this font library. Go back to our tool interface. We want to dynamically change the color of the text. We right-click on the text column. Get element ID. Select color. Inside the API, Ctrl-V. The second parameter. It is the color information we need to set. It is an ARGB 8888 format. A is at a high position. We give color information. You can choose the color of the character. Go back to the tool interface. If we want to make the string scroll, we need to tick it in the text scroll. This is when we regenerate the code. Right-click on the text G underscore element underscore ID. Select underscore score text Ctrl-V. Then the ID is underscore score at this time. Normal scrolling is every call to hours. Each frame displayed our characters scroll to the left. Jump a pixel. Our second parameter can be given directly to 1. Because user underscore process is called in a loop, we have it scroll 1 pixel to the left at a time, so that we can see it while running. My entire string can be scrolled to the left. Roll 1 pixel per frame at a time. When rolling to the point where all strings are not in the text box, it will scroll from the beginning again. If the way we want to scroll is circular scrolling, that is, I roll out the characters of the text box. If you need to scroll again at the end of the text box, then we can use it at this time. Still use the set_object_info ID unchanged. Then the second parameter uses this defined macro. There are 4 parameters in this macro. The first parameter is the left and right direction of scrolling. If you scroll to the left, give 0. If you scroll to the right, give 1. Then the second parameter is whether to loop or not. If we need to scroll in a loop, then this is the second parameter given to 1. Then the third parameter is the stride length of the roll. That is, the length and number of steps rolling. That is, the character that I rolled out of the tail. How much interval do I need from the tail of the string in front of me? Generally, we are in the tool. A pixel value has been set. This is the coefficient of the pixel value. So at this time we usually give 1. Then the number of steps rolled is also given 1. If this code runs, you can loop through this string. Roll out the string outside the screen. Will be displayed at the end of the character. This specific API introduction. You can check out our documentation. Back to the QD interface. Just now we introduced image and text. Now let's take a look at the button processing button message, mainly used for touch screen. QD supports touch screen. When the button receives the touch screen message will automatically press down or pop up, and then the other text and pictures can also be done, and then do the processing, and then mainly here. Is the second parameter of the user_process. The message of touch screen processing will be sent here. Supported messages include pressing, popping, long pressing, short pressing, and repeated pressing. And touch operations such as swipe to zoom. This is the button. So let's look at borrowing back to the tool world. Let's take a look at the image list first. Right-click, Add Image List. An image list is a number of small images of the same width and height. We put it together into a list bar. For example, our 1. We currently see the image list on the right. It consists of 3 100 by 75 images. At this time, our number of frame is 3. We have 3 images. Then the init frame is 0. When we set it to 1, the first one in the image list is displayed. Again, image list can support compression. The color format is also RGB 888. ARGB 8888, RGB 565, and many more. Then if we put the dynamic property on it, the XY width and height of our image list. Yes, you can change it in the API. To change it, for example, we make code, and then we right-click on the image list to get the elemental ID, then go to the API and go to Control V, the ID of the image list, and then the second parameter we can give the image list we need, the index 0 or 1 or 2 of the image list that needs to be displayed. Note that the total number of images in the image list should not be exceeded here. But QD will also judge. Then if we want to change the XY width and height of the image list, then back to the QD interface. Right-click on this image list to get element ID. We want to change its Y coordinates. Then the ID of the _Y is returned to the API Control V. Let's give the Y coordinate 20. Then if we compile and run it this time, we are the same as imagelist Y. It will become 20. Image list has many uses. It can be used to display different images in the same position and switch between images. Then we go back to the tool interface. Next, let's introduce how to use container. Containers are divided into static containers and dynamic containers. Static container not only plays the role of a display region, alpha changes to the entire area, and do a zoom. The zoom point is the center point in this area. When we want to change this reduction factor, then right-click on the min_content. Select get_container_scale. Then paste it into the API. The reduction coefficient is a floating point number, so we need this red definition too. HMI_F32_2_U32 to convert. For example, you want to scale 0.5x. So we have a whole picture. Scale to the center point of the container. Let's take a look at dynamic containers. Then container type. We choose dynamic containers. Dynamic containers are without locale. The role of dynamic containers. It acts as a switch. It can be specified to. Below it. Any container. For example, we add a set of containers under the dynamic container, with n containers, and then include image and add SImage in the middle, which is to add a set of images, select the compression format of the images, open the alpha channel, and set the prefix name. At this time, we can see that 7 static containers have been added under the dynamic container. And each of these 7 static containers contains an image below. It is not shown at the same time as these 7 images. We switch through dynamic containers. For example, when the index of our dynamic container is equal to 0. Then we will show image 24 in the whole picture. When the index of our container is 0. Then we are showing the container image 24. We can toggle the index of the dynamic container. When it is 1. We are showing the container image 25. When the index is 2. Then we are showing the container image 26. When the index is 3. Then we are showing the container image 27. This way we can use dynamic containers to realize the switching of themes and the switching of different screens. This is very easy to use. But if we want to change the dynamic container in the API, right-click Get Element ID on the dynamic container and select ID. Paste Ctrl-V inside the API. Our second parameter needs to be given a static container. That is, any child under the dynamic container. For example, we can give image 24 here. We also got the ID of image 24. Then we can give image 24 to the dynamic container. Then we are at the time of display. This dynamic container branch will only show image 24. Contents under this one container. Others 25, 26, 27. The contents below these containers are not shown. When we add a dynamic container, then select Video Input. This is a video input layer. The size of its video is determined by this width and height. The display position is determined by this XY. This layer is used to display video inputs. No elements are added below this container. In our dynamic containers, every child can share the same element. For example, we now have each container. Below are all different pictures. For example, there is a text. We can share at the same time. We can take this word as his child. We can also drag this text to image 25. In this case, when the dynamic container is cut to image 24, or when you cut to image 25, this new underscore text 13 will be shown. Sharing of elements can be realized. If we are text, we want it to have the same properties. But it is possible that a certain text is different. Or if a certain attribute is different. Then we can make a copy of this new underscore text 13. Then under the container that needs to be pasted, select Paste as New. It pastes a new element ID. You can see that the element ID we have pasted is called new underscore text 39. But all its properties are consistent with my new underscore text 13. All our elements can be pasted this way. Next, let's introduce the usage of spline. Start by adding a spline inside the main underscore container. The XY width and height here are the locations and areas where the splines are displayed. We can set the area and location. Spline type supports two ways. One is multipoint control. One is single point control. Multipoint control means that we have to put all the dots. Set it up in the QD tool. Give a container. Then it contains all the point XY information of this multipoint. Then a single point is to set a new point in the API each time. This point is generally located on the outside of our area. QD will move this point into the area each time. Similar to the effect of an electrocardiogram. Let's take a look at more. If you want more, we have a container point here. We need to give a set of information. So here we will create a new container first. Then under container we are. You can set 3 points first. 3 points are filled with fill. Add 3 files. Let's give it a name. This fill element below. We use its XY coordinates. So at this time we need to give XY. The first point makes it at the 0, 0 position. The second point is at the 100,100 position. The third point is the position of 200, 0. This forms an inverted triangle area. And here's a small detail. The width of this container is as the line width of the spline. So we need to change this width to the appropriate width. For example, we have a width of 5 pixels. Then set the width to 5. We return to the hard line. Inside the container point, select container. Select the control points we have set. Spline underscore point underscore container point is OK. Then below we need to set it up. The color of the spline. If you need to fill the area, here are a few ways. Fill the area down. Or fill the area to the left. Fill the area to the right. You can choose any here. If we give a Bezier curve, then you can do the Bezier curve. Fill the area down. Let's first look at the simplest downward formation area. At this time, we need to give two elements as fill colors. Or fill in the picture. Here it can be color. It can also be a picture. Let's give two colors first. We will give this color a blue. Then let's change the name. Spline_line_color. Let's add another fill. As a color _zone_color_fill for the area. We give a yellow color to this color. We can choose the color of the line fill. You can see the display window on the right side of our side. Splines have been drawn. Then we fill it with color as well. Because it is a downward formation area. So we can see the entire spline on the right. And this downwardly formed area is filled with yellow. This is the polyline, if it is a Bezier curve. Then we just need to choose this area. Form a Bezier curve downwards. You can see that our line on the right has become a Bezier curve. Then form an area downwards. That's when we generate code. We're inside the API. Of course, if this fill, it is a dynamic property. Then you can also change the position of the point of our curve in the API. This is a multi-dot spline. So that after we generate the code, we will compile and run it in the API. At this time, we can show it on the screen. Splines and the color-filled areas of the splines. Of course, our filling method can be a picture. Here are some renderings of what we did with the spline before. This video is our use of single point, 1 point. Do a display effect of energy consumption trends. How to set up a single point in the API. If we are a la carte, then we need to be in the XY coordinates given to it in the API. So let's get the element ID first. The ID of the pass to this spline. Inside the API, Ctrl-V. How to give this second parameter? We need to give 2 points XY coordinates. So we need to define it first. The X coordinate of the U16 bit. In defining the U16-bit Y, the X coordinate is always greater than the width of the spline. You can set the X coordinate to 405. The Y coordinate is defined based on the effect. Then we need to put the X and Y coordinates combined into a U32 type. So we also need a U32 variable, the control point. Control_point equals. We use a macro to combine it with X and Y points. HMI_2U16_2_U32X, Y. At this time, put our XY. Variables are given. This is how it is set up in our spline. As long as we set the point differently each time, then a set of point information will be formed. This is our 1 point. Back to the QD interface, let's introduce. This is the basic element of QD, we have covered it. Next, let's take a look at the font in resource. We can load the font library that we need in our project first. Font range, you can preset the range of a font library first. If it is a Chinese character, the scope of use may be relatively large. Here we can choose the font we want. And the glyph size, click to confirm. Then QD will put the words we set in the font range. And the initialized words in the middle of the already preset text element. Will generate character.matrix. Of course, QD also supports vector fonts. When we tick this off, by default, this is a vector font library. Ticked is a .matrix font library. All words are in the form of generated numbers. Below you can choose how our font library is displayed. Normal is normal landscape display. Then all our characters can be put together. Rotate 90 degrees or rotate 270 degrees. File name. We can also use some of the font libraries. Organize it into a TXT file. But note that this TXT file needs to be converted to Unicode encoding. The encoding mode that needs to be saved as Unicode is required. Then we put the TXT text here after selecting. We will also generate this in this font. Characters contained in the TXT text. Next, let's talk about string. String is designed to support multiple languages. We can set the languages we need to support here. Up to 50 languages are available simultaneously. We can see after adding string here. As long as we have set up the language, then we can give it preset text in this property. When switching languages in the API, all our non-editable text, they are automatically switched according to the text. No need for customers to put each one. Text. So how to do it? This is our preset string. Back to our development interface. At this time, if I add a text, this is our new text. If the operation is wrong, here is a button function that can delete the operation just now. We see the edit text in the upper left corner. So if we want the text to be fixed, immutable, and multilingual, then we can change the non-editable state to true. Then on the static init side, we select a string. Then select our preset new string 11. Because the default language in our string is English, so we see that the display on the right is in English. This is if you want to switch to Chinese development. Then change its init language to Chinese in this string. Then you can see in the application that we are displaying the Chinese format. Because our text has a number of chars that only has 6 characters. The preset characters exceed our number of characters. So change the number of chars to 10. And the width should also be increased. You can see that the Chinese characters can already be fully displayed. This is string multilingual. How do we switch language modes in the API? QD generates the corresponding ID of the language. Then we also call the API to set it up. Set object info. The first parameter gives the language macro HMI_language. Then the second parameter. Give us the target language we want to set to. For example, we currently have English and Chinese presets. So if we want to set it to English display, then we can set it to HMI_English. As long as it is multilingual set in the tool. All our texts are cut to English. If it is the second parameter, we set it to HMI_Chinese. Text cannot be edited. Will be cut to Chinese mode to display. Switch to Chinese character display. The following is an introduction to the Bezier curve. We can preset a Bezier display Bezier curve here, right-click, then we can add our control points. Dragging the whole distance can adjust the shape of our curve, and after adding the Bezier curve, we can use this Bezier curve for the motion trajectory of our animation. For example, we want to move this picture with the Searle curve we just preset. At this time, we first tick the dynamic attributes of this image. It needs to be a dynamic picture with variable XY width and height. At this point, we go to Action to create an animation. Let's add an event to the custom events first. In the event, we need to add an action entrance entry. Under this entry, we can set a timer. What the timer does is set the time when our animation starts and how long it lasts. For example, after we start from event, we start. Then the duration time is 2s. Then we set an action below, under timer. The goal of our actions is the dynamic image new _ image 5 we just set up. We want the XY coordinates of the new _ image 5. Move along our Bezier curve. Then we select position for action type. It is the coordinates of the position where it is moved. Here's a linear change. We can set the starting coordinates of XY and end coordinates. When we want it to move along the Bezier, we need to set it up. At this time, we have a line of motion path. Remove its tick. We choose one below the Bezier curve we just set up. You can choose the animation type below. To move along the Bezier curve for 2 seconds, we can choose linear motion, or from fast to slow movement. Movement from slow to fast. So it can also be a slow movement. Let's first look at the effect of linear motion. After set it up, we can do it directly. Right-click on this entry. Run action. Let him run it here. Then here you need to choose under which page do we activate. Select a page and click OK. You can see that our picture is along the preset we just preset. The Bezier curve is the movement of the path. This is our Bezier curve. The Bezier curve also uses our animation QD preset animation function. So here is the set action. In addition to being able to set the change in position, it is also possible to change the width and height of our images. Or we can set up our dynamic containers. Then there is the switch of the page toggle. Or set our text. And our color changes, alpha changes. Then set our angle. You can also set the scrolling stride length of the character. Set the button, set the image list, and set the scroll bar. You can also use the call function. It is when I am executed. I call one of my functions. This call function. You can give the function name to QD here. Then when the action is run, we will tune into this function. Then we add some of the above in addition to the call function. And his scale. P1, P2, P3 is a change in some custom values. As long as this event is activated, then the actions below it will be executed. We want to perform this action by activating the event. So how to activate this event? The API is written like this. Right-click to get the ID of the event. Then go to our sourcing inside user_process and Ctrl+V paste. Once we get this event, we can be here. HMI_action_run. In this case, we can activate the animation display. One thing to note here is that this event cannot be activated all the time. It can only be activated once when an event is being held. Then the actions below it can function normally. In addition to the fact that we can activate the event, we can also execute the entry directly. You can also get the entry ID. Then Ctrl+V gives it a HMI_action_run directly to this entry. Then if after activation, we want the animation to pause or cancel quickly, then we can do the same. We also use this API and the event ID. But the second parameter, we can give pause a pause. Then fast_finish is fast execution. Quickly execute my action. That is, 1 frame. For example, I set the time to 2 seconds. Jump straight to the 2-second result. Then pause means I stop performing this action. QD is supported in addition to support action. The function of animation presets can also support the function of state tables. Then we can be in. This status table is inside. Add our event information and status. The left column is the status information. The top row is our event information. We refresh the last column to add later. When the event happens, we can preset our animations in the state. Which animations need to be executed? Here are a few image conversion plugins made by QD Tool. In Tools, if our image is in RGB 888 format, We want to convert it to RGB 565 format. Then you can use our RGB 888 to RGB 565 here. You can select our picture, click to open. Then QD will convert the RGB 888 color format image into an RGB 565 image. This ensures that the code is not discolored after it is generated. No frame loss. Unless it's a picture with very delicate gradient colors. There will be a slight frame loss. This is a picture conversion. Then there is also the modification of the compression format. At this time, we can change the compression method of a certain compression format to a new compression method. For example, I want to change RLE lossy to RLE no loss. After confirming, the compression format of all images originally set to RLE lossy will be changed to RLE no loss. There is also an XML import and export function in the tools. For example, the two of us are working on a project at the same time. Then I need to add some of the new ones. Merge into my XML main project. You can output the current element first. Export a set of branches to it. Hit it first and then open the XML I need to import. Then click on the input element. Import the branch you just exported. This is very practical when developed by a team. Then ARGB 8888 pictures are also supported. Convert to ARGB 4444.